So let me start with the syllabus. So the first chapter will be your network analysis. Okay. The first chapter will be your network analysis. Network analysis. With how to analyze a circuit. Okay. So there are maybe two types of circuit. Part we will.
There is a sound problem from my side. I don't think.
Okay.
Connect.
So anybody else is getting the sound properly or not?
Yes, sir.
Not properly, sir.
Arana?
It's lagging in between, sir.
Lagging between. Is showing. Okay. Is it okay now? Oh, it's still lagging.
Yes, sir.
Okay.
It's okay now.
Okay. So we have a resistive circuits, and there will be circuits which involve capacitor and capacitors and inductors. Okay. The second chapter will be on semiconductors. Okay. So in semiconductor, I will discuss two things. One thing I will discuss fundamental of semiconductors. Fundamental of semiconductors. Semiconductors. Okay. Fundamental of semiconductor. And second part of this chapter, I will discuss basics of PN junction. Basics of PN junction. Okay. So PN junction is a very important topic because all of your devices, okay, is made of PN junction. Okay. Whether you call it transistor, MOSFET, okay, solar cell, tunnel diodes, any LED. So any electronic devices, there is a role of PN junction. So it is very necessary to understand the basics of PN junction. And the third chapter will be diode. Okay, diode and its circuit application. It's okay. Their application, rectifiers, voltage regulations, and clamping, clipping. So all these things comes in chapter 3. Okay, and the chapter 4 will be dedicated to transistors. Okay, transistors. Okay, and basically we'll discuss BJT, bipolar junction transistors. And the last chapter 5, okay, we'll take a linear device called op-amp. Okay, this is operational amplifier. Op-amp, operational amplifier. And its applications. Okay, and its applications. Okay. So diode and transistor, basically they are non-linear devices. Okay, and op-amp you can consider as a linear device. So we'll discuss what is non-linear, linear. Okay, so this is my layout of this course. Okay, and today I'm starting with this network analysis. So put the heading network analysis now. Network analysis. So let me first define what is the network. Okay. So network is basically interconnection of network elements. Okay. So what is network? Okay. Network is connection of network elements. Interconnection of network elements is called your network. Okay, interconnection network element is network. It's called network. It's called network. Now, what do you mean by network element? Network element क्या होते हैं? Okay, so network element का मतलब है नेटवर्क एलिमेंट का मतलब है मेरा रेजिस्टेंस है. ओके, R is a network element. Similarly, inductor, capacitor, okay, diode, transistor. Okay. Then energy sources like voltage source, current source. Okay, these are called network element. Okay, any type of interconnection between these network elements is called your network. Okay, so let me draw a network. Say I have a voltage source. Okay, I have voltage source. Say I have a resistance R1. This is resistance R2. And say this is resistance R3. Okay, and this is the upper terminal. Now, this is example of a network. It's example of a network. Okay. Now, network and circuit words are interchangeably used. Okay, in the electronics. Okay, so we generally roughly we call circuit. Okay, but network and circuits are not two same things. Okay, there is a slight difference between a network and circuit. Okay, the word circuit comes from circle. Okay, so if you want to call in interconnection a circuit, okay, the first condition is it should be closed. Okay, so a closed loop can be called circuit. That is the first requirement. And the second requirement of circuit, when I call circuit, there should be an energy source necessary. Okay, so for example, this is my example of network. This is open here. A circuit cannot be open, so this hole cannot be called a circuit. Okay, and if I say the closed path in this network, this is a loop. Okay, loop. So loop means what? Loop means a closed path in network or circuit is called loop. A closed path in network is called loop. Okay, and a closed loop with energy source is called circuit. So this part of this loop I can call this is a circuit. Okay, so this is my circuit. Okay, it is basically closed loop having, okay, an energy source. Okay, is called circuit. Okay, now network circuit के लिए energy source ना जरूरी है. Okay, but network के लिए we don't require there should be a energy source. For example, if I remove this energy source here, okay, still it is a network. Okay, but that is called now passive network. Okay, that is called passive network. That is called passive network. If I remove the energy source, so depending on whether there is an energy source present or absent, okay, network can be classified as a active network and passive network. Okay, so now what I can say all the circuits are network. Okay. All the circuits okay, fall into the category of network. Okay, so all the circuits are networks. Okay, but all the networks are not circuits, are not necessarily circuits. Okay, so I hope you understand what I'm saying. Okay, so all the circuits are networks. Okay, this is network. Okay, but this cannot be called circuit. But circuit can be, any circuit can be called network. Okay, so you can assume network is a set, and circuit is just a circuit is the part of this set, or you can say subset. So network can be without the source, but circuit cannot be without the source. Okay, that is the difference between a circuit and network. Okay, I hope the definition is clear. Okay, so this is the first part. Okay, so what is the difference between a circuit and network? Okay, now the second part comes. Okay, network terminology. Okay, how we understand network. Okay, so the next is your network terminology. So before I discuss this network terminology, okay, so we would understand in network what we are looking for in the network. Okay, when I say network analysis, okay, so basically what does this mean? Okay, so network analysis means I am trying to find the voltages, currents, power, or charge. Okay, depending on the element present in the circuits. Okay, so there are some basic quantities in electric circuits. Okay, so what is the basic quantities? So basic quantities in electric circuits or electric networks. Okay, now I will call for circuits for simplicity because I'm going to use source everywhere. So basic quantities in circuit. Okay, so what are the basic quantities in circuits? The first is your charge. Okay, charge. And you know what is charge? Charge is the fundamental property of matter. Fundamental property of matter. Okay, charge is given by Q Ne. Okay, where n can be 0, 1, 2, 3, so on, and E is your electronic charge. E is the electronic charge. Okay, the value of E is given 1.6 into 10⁻⁻19 coulomb. The second part is called your current. Second basic quantity is current, which we want to find in the circuit. Okay, current, and you know, all of you know what is current. Okay, the rate of flow of current. Rate of flow of current. Okay, mathematically, if I write current mathematically,
Sir, charge.
charge क्या हो गया? What is charge?
So rate of flow of charge.
Rate of flow of charge. Rate of flow of charge. Okay, it's called current. So if I write I, so I will be your dq upon dt. So mathematically, this is the definition of your current. Okay, and the third important quantity which we are going to deal in the circuits is called your voltage or voltage difference. Okay, so voltage is basically defined as a work done. Okay, a work done. So what is the definition of voltage? Can anyone tell me what is the definition of work done. So energy or work needed. Okay, so energy or work needed. Okay, needed to move a charge from point A to point B in the circuit. Point A to point B. Okay, the energy required to move it or work needed to move a charge from a point A to B is called your voltage or voltage difference. Okay, so if I want to move a particle from a charge, okay, from Q charge Q from point A to point B, okay, then I can call the voltage difference will be dW by dQ. Okay, so and similarly we know in the circuit that VAB is equal to minus VBA. Okay, what does that mean? So अगर हमारे पास circuit में we have two terminals A से B, okay, and see this is ground. So if the voltage of A with respect to B say 9 volt, okay, this is ground and is 9 volt. So the voltage of terminal A is 9 volt compared to B, and other, but I can also say the voltage of B with respect to A is minus 9 volt. Okay, so voltage VAB, A with respect to B is plus 9 volt, or if I say VBA, I can say this is minus 9 volt. Okay, so in the circuit VAB equals to minus VBA. Okay, so three quantities, important quantities: charge, current, voltage, and the last is power. So this power, what is power? So fourth quantity is power. Okay, what is power? Tell me about, anyone can tell what is power?
Energy loss per second. Sir.
Okay, so energy क्या है? Energy है वन एबिलिटी. ओके, एनर्जी किसी सिस्टम की एनर्जी डेंसिटी बहुत ज्यादा है, जैसे बैटरी है उसकी एनर्जी डेंसिटी कैपेसिटर से ज्यादा होती है, फ्यूल सेल है उसकी एनर्जी डेंसिटी बैटरी से भी ज्यादा होती है. ओके, तो एनर्जी डेंसिटी क्या होती है? एनर्जी होती है एबिलिटी टू डू वर्क. ओके, और कोई डिवाइस कितना फास्ट वर्क कर सकती है, हाउ मच फास्ट इट कैन डिलीवर करंट, दैट मींस एनर्जी, that is called power. Okay, so ability to deliver, how fast you can deliver power, that is called energy, that's called power. Okay, so power is basically defined as power. Okay, so power का मतलब होता है dw upon dt. Okay, so you can write the rate of work done. Okay, rate of work done okay, or rate of energy flow, or rate of or energy flow. Okay, how fast a device can deliver power. Okay, rate of energy done or energy delivered, rate of work done or energy delivered, okay, is called your power. Now this I can write d omega by dq. Okay, so since I'm dividing by dq, I have to multiply by dq. This is dt. Okay, and dw by dq is, I told you, this is a voltage in the circuit, and dq by dt is your current in the circuit. Okay, so if through any element, if I want to calculate how much power it is delivering or how much power it is absorbing. Okay, there are two type of element in the circuit. One is called energy source, which provide power. Okay, current source which provide power, and there are the element like your capacitor, like your inductor or resistors. Okay, which dissipate this work, dissipate this energy. Okay, so कौन सा एलिमेंट कितनी पावर ले रहा है या दे रहा है, ओके, दैट वी कैन फाइंड बाय VI. ओके, सो अब रेजिस्टेंस है, रेजिस्टेंस का अक्रॉस कितना वोल्टेज है, उसमें से कितना करंट फ्लो हो रहा है, If you multiply by V by I, that will tell us how much power it is dissipating. Okay. So this is the 4 basic quantities जिनकी हमको circuit में जरूरत पड़ेगी. Okay. So that we are going to deal in this part of network analysis. Okay. Now we'll come to the topic or title network terminology. Okay. So now we'll try to discuss what is your network. Okay.
सर वोल्टेज और पोटेंशियल को सेम बोल सकते हैं.
हाँ, पोटेंशियल तो हम सेम बोल सकते हैं. पोटेंशियल क्या होता है? इनफाइनाइट से किसी पॉइंट यूनिट चार्ज को लेके आने के लिए जो वर्क डन होता है, दैट इज कॉल्ड पोटेंशियल. ओके. सर्किट में जनरली वी आर इंटरेस्टेड इन वोल्टेज डिफरेंसेस. ओके. तो वो एक ही चीज है वो सर्किट में. वोल्टेज बोल दो, पोटेंशियल बोल दो, वोल्टेज डिफरेंस बोल दो. ओके. सो नाउ network terminology. So let me draw a network now. Chalks are not good. This is the voltage source. Let's say R1. This is R2. R3. And say I am putting here a current source. Okay, so these are energy source, voltage source, and the current source is a symbol of current source. Okay, independent source. Okay, these are independent sources. Okay, is plus minus. Okay, V, and when I call this, these are voltage source and current source, and they are called independent sources. Independent energy sources or energy sources. Okay, why I call them independent sources? So suppose if it is written here 5 volt. Okay, so this will give you always 5 volt regardless what is the condition of the circuit. It's independent. If it is a 5 volt, it will give 5 volt. Okay, if it's written 10 volts, it will give 10 volts in the circuit. Okay, and similarly, if the current source is of 10 ampere, it will give you 10 ampere. Whether what is circuit here doesn't matter. That is called independent source. Okay, they do not depend on the circuit conditions. And there are some sources which is called dependent sources. Okay, that we are not going to deal right now in the circuit in this chapter. Okay, dependent sources are those circuit sources which for if you say dependent voltage source. So its voltage difference, how much voltage difference across this source depends on the circuit condition. Similarly, how much current is passing through that element, that depends on the circuit conditions. Okay, so voltage and dependent sources are basically used in modeling. Okay, if I want to model a operational amplifier or a transistor by some device, so there are some dependent voltage sources we use. Okay, we'll come to that later part of this course. Okay, so here I'm only going to discuss the simple voltage circuit, current circuits which are independent. Okay, which values, okay, does not change, okay, with the circuit. Okay, so this is my independent sources. Now in this circuit I want to define node. What is node? Okay, node. So anyone tell me what is the node? Okay, so node का मतलब क्या है? So here we have this is my terminal, this is my terminal, this is my terminal. Okay, terminal. Okay, so a terminal between okay, a terminal where 2 or more network elements join. Okay, a terminal where two or more network element join. Network elements join, okay, called terminal. Okay, so network element का मतलब क्या है? ये network element है 1 2 3 4 5. These all are network elements. Okay, so a terminal where two network element join is called your node. So can you tell me how many nodes are there in the circuit? So, oh, new students, okay, how many nodes are there in the circuit? Anyone? कितने कितने नोड हैं सर्किट के अंदर? Can you count? First tell me how many terminals are there
8 terminals.
and node, how many nodes are there?
Eight nodes.
See, eight cannot be nodes. Okay, the definition is 8 terminals where two or more network elements join. Okay, so this is network element, this network is joining.
5.
So this is a node. Okay, let me calculate. This is a node 1. Okay, this is the network element, this is the network elements joining here. This is a node 2. Okay, now here this node, this terminal, and this node and this nodes are same because they are in same potential. In between there is a no component. Okay, if some the voltage is here 5, so this voltage will remain 5 here also. There will be no change. They are same point. Are you getting? They are not different points because they are short circuit. I don't need this line. This just a schematic to show the circuit. Terminal जो एक ही है. I can take this terminal and put here. Nothing will change because in these two terminals there is nothing. No network element is there. Are you getting? This is just a way of drawing. This line means nothing. I can simply take this line component. I can join here. This drawing looks this explanatory. We are drawing this line. Basically, this line means nothing. This is a short. This is short because there is no resistance between there, no component between there. So this point and this point are same, and this point are same. So this whole 3 is called single node. Okay, this is a single node. यहाँ पर we are 2 elements are joining. Here 2 elements are joining. Okay, then here this point, this point, this point, this whole, because they are short circuited, they are same potential. So this is called single node. Similarly, I can say these terminals which are short circuited, they all terminals are same potential, so they can be called as single node. Okay, so in this circuit we have a total number of 3 nodes. Okay, so the number of nodes are 3. Now the next is branch. What is called branch? Okay, how many branches are this circuit? Okay, so a component between two nodes is called branch. Okay, क्या मतलब है? कंपोनेंट का मतलब क्या? कंपोनेंट यही है जो कि एक कंपोनेंट एक ब्रांच है. तो सर्किट में कितने कंपोनेंट है? 1 2 3 4 5. Okay, so the component between two nodes. This component, this is one node, this is one branch, this is another branch, 3 branch, 1 2 3 4 5. Okay, so here we have in this particular network we have 5 branches. Okay, we have 5 branches. Okay, now the third definition is called, third definition में क्या है? लूप कितने हैं सर्किट के अंदर? How many loops are there in the circuit? Okay, So let me call this as a B, say this is C, D, say this is E, F, G, H. Okay. So how many closed loops are there in the circuit? Can anyone count? कितने closed loop है circuit के अंदर?
6.
6. Okay. 6 है. कौन सा है? You have A, B, G, H. ये closed loop है. A, B, G, H. Then you have B, C, F, G. This is closed. B, C, F, G. Then you have a C, D, E, F. C, D, E, F. Then you have a C, F, H. A, C, F, H. Then you have B, D, E, G. B, D, E, G. And then finally you have a bigger one, A, D, E, H. A, D, E, H. Okay. So in the circuit, total number of loops are 6. Loop means closed path. So a loop is, I already defined, loop means a closed path in the network. A closed path in the network is called loop. Okay. So this is the definition number 3 in the network. Okay. So these definitions are necessary to understand the circuit. Okay. So this circuit terminology. Now the last is called mesh. Now mesh, all of you know, because you have studied in your school and colleges mesh current method. Okay. So what is mesh? Mesh क्या होता है? What is mesh? So basically your mesh is an independent loop, and independent loop. Okay. Independent loop का मतलब क्या है? A loop. Okay. A loop which does not contain any other loop inside it. Any other loop inside it, it is called independent loop. Okay. जैसे अब ये loop है A, C, F, H, ये closed, this is a closed loop, closed path, this loop. But this cannot be A, C, F, H cannot be called mesh because it is not an independent loop. It contains the loop A, B, G, H inside it. Okay. So only the independent loop, as the loops which does not contain any loop inside it, is called the meshes. Okay.
3.
So we have 3 meshes in the circuit. Okay. So we have 3 meshes. If I say number of meshes, how many meshes are there? We have 3. Which one? A, B, G, H. A, B, G, H. They are independent loops. B, C, F, G. And then you have a C, D, E, F. Okay. So these 3 are called meshes. Okay. And there's a relation between branch number for any network element. Okay. We can prove. Okay. There's a theorem which comes from circuit topography, which says the relation between E, M, and N is given by this equation. Okay. For example, in this given circuit, we have 3 meshes, 3 nodes, -1. So we have 3, 3, 6, -1, 5. So we have 5 branches, and you can count there 5 branches, 1, 2, 3, 4, 5. Okay. So this relation always holds in a network. Okay. So branch number, mesh number, and node number, they are connected by this expression. Okay. Now, where we have reached so far? Okay. The chapter is network analysis. Okay. So we have talked about network definition. Okay. We talked about the quantities which we are going to deal in the circuit. And we have also talked about a basic terminology. Now the main job for us is network analysis. Okay. Network analysis means you want to solve the circuit. So what is network analysis now? Okay. So network analysis. Okay. Network analysis का मतलब क्या है? Network analysis means finding the basic quantities. Okay. Like or finding voltages and currents across each component of the circuit is called network analysis. So basically you want to find you have a given circuit where you have a resistance, inductor, capacitor. So what is the current flowing through each capacitor as each element, and what is the voltage across each component? That is the purpose of network analysis. Okay. So it can be you may be asked in the question, calculate the current in a branch, calculate the voltage across any component, or calculate the power through any element, or how much charge is flowing from particular point or for particular through a particular element in the circuit. Those basic quantities calculation is called your network analysis. Okay. So but how do we do network analysis? Okay, how do we perform network analysis? Okay, so there are some basic fundamental things by which we can approach a network. Okay, so what are the techniques, or what are the ways for network analysis? We will learn these ways, methods and techniques. Okay, so the first method is called, first is your basics law. Okay, using the basics law you can solve a network. Okay, what are these basics law? These basics law are called Ohm's law. Ohm's law पता है? Okay, suppose अक्रॉस रेजिस्टेंस आपको पता है कि कितना करंट फ्लो हो रहा है, okay, कितना voltage, as you want, if you know the resistance and you know the current, okay, you can find how much voltage is there. So these laws can help us to do network analysis or solve a circuit. So basic law, the first is Ohm's law, second is your Kirchhoff's current law, third is called your Kirchhoff's voltage law. These are three fundamental or basic law which we are going to help us to solve a circuit. Okay, but as complexity increases, okay, then this law will take time. Okay, so we want some efficient techniques by which we can solve easily. Okay, the time with a short duration of time. Okay, our purpose is to solve a circuit efficiently. Efficiently का मतलब है कि that should not take much time. Okay, we can quickly able to solve any circuit. So this basic law you can solve the simple circuit, but as complexity increases, okay, or circuit become larger or more complicated, then you need some techniques. So this is called techniques. Okay. These techniques, so one is called your nodal analysis. And the second technique is called your mesh analysis. Okay, mesh analysis. Okay, nodal analysis basically is the combination of Kirchhoff current law. This is called KCL. This is called Kirchhoff voltage law, KVL. So nodal analysis basically is a combination of your Kirchhoff current law, KCL, plus Ohm's law. Okay, and the mesh analysis is a combination of KVL plus Ohm's law. Okay, so these are the two important technique to solve quickly a circuit. Okay, and if you want to go further, you want to increase your efficiency further. Okay, you want to solve, so then you need some network theorems, okay, which can help you to solve a circuit very fast, okay, fast and efficiently. Okay, that is called, after that we learn first basic law, then we learn techniques, then we learn network theorems. Okay, and network theorem, the most important theorem is superposition theorem. Okay, then the second one is your Thevenin's theorem. These are two important theorem. Or what I'm writing, all are important. Thevenin's theorem. Okay, and the third is called slight modification of Thevenin's theorem, is called Norton's theorem. Okay, and there is also called source transformation, which we do not require, okay, much, but I will just give you the introduction, okay, in case you want to use this one. Okay, source transformation. Okay, so these are basically the tools, okay, to solve a circuit. Now, if you have a command on one or two method, like if you have nodal analysis, you can solve almost all the circuits. Okay, nodal analysis ho gaya. Okay, then if you know this network theorem, especially superposition and Thevenin's theorem, then you can solve any circuit, okay, without any problem. Now this chapter is very important. Okay, now if I say add such the questions from this part of the circuits, okay, very less. Okay, so if you have 3 exams like JEST, NET, GATE, JAM, okay, so out of this four exams you can get only 1 or 2 questions per year. Okay, sometimes you get one question from gate from this net analysis, or some question from JAM. Okay, but that does not decreases the importance of this chapter. Okay, because this is the fundamental chapter. Without learning network analysis, you cannot deal electronic devices. Okay, because हमारे कोर्स में जितने भी क्वेश्चंस आते हैं, डायोड हो गया, ट्रांजिस्टर हो गया, ओपैम्प हो गया, तो सर्किट में उसको डाल देते हैं, and then we are asked to solve the circuit. Okay, that's why this chapter is most fundamental, and we are going to put some effort or some time. We are going to input some time on this topic. Okay, if you 6 to 7 classes. So the questions which I'm going to solve here, okay, they may be slightly difficult, okay, but that will enhance your ability. Okay, the later part, what we are going to circuits like diode ka circuit hai, transistor hai, diode op-amp hai, these are simple circuits. Okay, but sometimes if you questions comes which are tough in exam, okay, so I will give you some 30 to 40 problems we'll solve in this network analysis. Okay, that will give you all overview what type of skills you require to solve any circuits. That will enable you to you're equipped with you that the tools. Okay, that is the purpose of this chapter. Okay, now I'll take each and everything by one, and we'll discuss what is Ohm's law, Kirchhoff law, current law, these techniques. Okay, and we'll solve the circuit using these all tools.
सर नेटवर्क थ्योरम इतनी है बस?
हाँ?
नेटवर्क थ्योरम इतनी होती है और भी है?
और भी है, पर हमको जरूरत नहीं पड़ेगी ना, हम हमारा काम इससे चल जाएगा ना, ये मेन थ्योरम्स है. तो
ओके सर.
हमारा पर्पस नहीं है कि our purpose is not to learn network analysis. Okay, but we are not engineering students. Okay, so we have to use our time smartly. Okay, जितना हमको जरूरत है उतना ही हमको करना है. Okay, because we are mainly we have to deal with devices, not we don't want to become expert of circuit analysis.
ओके सर.
So now let me discuss the basics law. Okay, the first is Ohm's law. Okay. So Ohm's law is what? If you apply a voltage source, okay? If you're applying a voltage source, this is a voltage, so not voltmeter, this is a voltage source, okay? So you're applying, let me better to draw like this. Okay. You're applying a voltage source here. The circuit is plus minus. Say I current is flowing, okay? This is a potential, is higher point, this potential here is higher, it is lower, okay? So here V potential, here drop is there, and remaining potential come here. So if I put a voltmeter here, okay, if I put a voltmeter here, putting voltmeter plus here and minus here, and I ask what is the reading V here, okay, so this resistance is R. So what is the reading here? V will be equals to what? V
IR.
IR. V will be equals to IR. That is Ohm's law. Okay. So if a resistance is here, current I is flowing, so resistance R. If I put plus minus here, that is the polarity. That means I am measuring voltage like this. My voltmeter plus is there, minus is there. In this case, I can write V is equal to IR. But same circuit, same here. I am applying voltage like this, but I am measuring like this. My current is flowing in this direction. Current is flowing in this direction. Okay, but I am measuring voltage here V. Then V equals to what?
minus IR.
Minus
Minus.
IR. So circuit में जब भी मिले, this sign convention you have to remember. This is called sign convention. So here ये plus minus जो मैं लगा रहा हूँ, basically this is a polarity to the voltmeter. How you measuring? अगर मैं ऐसे measure करूंगा तो voltmeter multimeter है, digital multimeter है, तो मुझे positive value दिखाएगा. अगर मैं इसको इस voltmeter का ऐसा लगा दूंगा उल्टा, then it will show me the negative values. Okay. और अगर एनालॉग वोल्टमीटर है तो क्या एनालॉग वोल्टमीटर कैसा होता है? ओके, यहाँ पे स्केल होती है. ओके, यू हैव स्केल लाइक दिस, स्केल होती है 0, तो यहाँ पे वो पिन होता है. तो अगर पॉजिटिव है तो ये वैल्यू दिखाएगा पॉजिटिव, और नेगेटिव है तो पीछे अटक जाएगा ऐसे करके. इफ जीरो अगर बीच में नहीं है आपके वोल्टमीटर में, अगर एसी वोल्टमीटर नहीं है, प्लस माइनस दोनों नहीं है, खाली डीसी वोल्टमीटर है, then it will not show negative values because negative value होती नहीं है. Okay, so that is the polarity how I am measuring voltage. If I measure like this, I should have VIR, and if I measure like this, this should be minus IR. Okay, that you should remember. So that is your Ohm's law. Okay, so your V is proportional to I in a circuit in any element, and that is IR. That's Ohm's law. Okay. Now second is, the second law is Kirchhoff current law. Kirchhoff's current law. Okay. So what this law says, to a node is 0. Okay, algebraic sum of currents
सर साउंड चला जा रहा है बीच में.
sound हाँ भी चला जा रहा है. चेंज माइक्रोफोन चेंज हो रहा है. He says this device is not recognized.
Just give me 1 minute.
Okay. So algebraic sums of current to a node is 0. Okay. So if I say this is my node and current is coming here I1, okay, and I2, and current leaving is I3, okay, the current leaving is I4, okay. So this law says algebraic sum of currents to a node is 0, okay. So that means if I take, so now some currents are coming in, incoming towards the node, some are leaving, okay. Now it is your choice which current you want to take positive or which current you want to take negative, okay. So KCL will take care of everything, just you have to choose, okay, whether you want to take incoming current positive or outgoing or leaving current as a positive, okay. So I generally take incoming current as a positive, or whatever, outgoing current is a positive and incoming current is a negative, okay. So here let me take incoming, let me take incoming currents positive, okay, incoming currents positive, okay. I generally take outgoing current positive, but just, okay, for example, now here incoming currents positive, and incoming means the currents coming towards the node, okay, and the current leaving to currents leaving the nodes, leaving the node, okay, call them negative, okay. So algebraic sum of currents, okay, that is I1 I'm taking positive, the incoming I2 I'm taking positive, and this I'm taking I3 negative, and I have taking negative. So I1 plus I2 is equals to I3 plus I4, okay. What does mean? That incoming currents equals to outgoing current, sum of incoming currents, sum of incoming currents is equal to sum of outgoing currents, okay. Now this law is basically conservation, this law is related with the conservation of charge, okay, conservation of charge, okay. So conservation of charge means the charge, how much charge is coming, okay, that much charge is leaving, okay, because in the circuit there is no accumulation of charge at any point, किसी भी point पे आपका charge accumulate नहीं होता है, okay. So there is a, you can write no accumulation of charge, no accumulation of charge at any node, okay. क्योंकि चार्ज का accumulation नहीं हो रहा है, तो जितना चार्ज आ रहा है उतना जा रहा है, okay. That means you can say I1 plus I2 equals to I3 plus I4, okay. So that's the meaning of this law. Now let me solve a simple problem, okay, quickly in 5 minutes using this technique, okay. So I know one law, that means I know one tool, I know Ohm's law, I know KCL. So using with these two, at least I can solve something, okay. So it's a simple circuit. So basically this is defined on a, so plus minus 10 volt, okay. So this is circuit. So you can call anything, say this is R1, say this is R2, and say this is R3, okay. And then this you have this 5 amp current coming from here, okay. Say this source is giving you 3 ampere current, assume 3 ampere current, okay, and this 5 ampere current. Here current is say 2 ampere, okay. So the question is, what is the value of I, okay. So find I. How can I calculate I? So just you have to apply अभी कुछ नहीं अप्लाई करना, अभी तक हमने we have just learned the KCL. Just apply KCL and tell me what is I. What is I? So first you have to see node कहाँ पर है. So this is your node. This is your node, and this whole is one node. I call it A. I call this node B, and these all are short circuited. So this whole is called your a node C. So we have 3 nodes. Okay. Now we have to apply KCL. KCL is always applied on what? Node. Okay. So apply KCL at node B. Okay. And tell me what is the value of I. The KCL is incoming current equals to outgoing current. So node pe, in node, how many currents are coming and how many currents are leaving? Make them equal and tell me what is I.
1 ampere.
1 ampere. How?
3 equal to I plus 2. Then I equal to 1.
Anyone else? For your
6 ampere.
6 ampere. Anyone else? कोई और बता रहा है?
6 sir, 6.
2 ampere. Okay. We see 3 ampere current is coming towards this node. 5 ampere is coming towards this node. So incoming current is what? 3 plus 5. ये current आ रहा है. This current is coming towards this node. This is one node. This is one point. This current is coming. Okay. How much is leaving? 2 ampere. This nodes पे कितना जा रहा है बाहर? How much is going? I. So I will come what? 8 minus 2, 6 amperes. Okay. So ऐसे नोड पे हमको एनालिसिस करना है कि कितना करंट आ रहा है, कितना करंट जा रहा है. So that will give you the unknown current. Okay. तो एक ऐसा क्वेश्चन और कर लेते हैं फटाफट. तीन वोल्ट RA. We have 6 ohm, 5 ohm plus Vx, and this is my. Okay. So first you have to identify the nodes. Okay. And this time they are saying this source is giving me 8 ampere current. This source is giving me 13 ampere current. Okay. So find out now. Okay. 13 ampere current is coming here. Okay. 8 ampere current is coming here. So he says find Ix. Find Ix. Okay. Ix current going here. Ix. Find Ix and RA. Okay. Find Ix and RA. How to calculate? Nikala, very good. Good question. So tell me what is Ix and what is RA? Of course, there is some current is going here also. So that current is IA. Yes, that is current is IA. Now you have to use the Ohm's law and KCL, both the things. First, tell me what is IX. V equal to IR, Ohm's law. If you know voltage, you know resistance, you can find the current. So what is IX? So now we have two currents known, two current unknowns. So you cannot apply KCL. भी चार में से तीन तो पता होनी चाहिए. तो हमको पहले तो अगर हमको लगाना है KCL तो हमको IA या IX में एक पता होनी चाहिए. We should know one current at least first. So which we can calculate first, IA or IX? इतना टाइम नहीं लगता है. Just see the circuit. This is the 18 volts coming across this one.
IX is 3 ampere.
Very good. This is 18 volts coming here, and you know resistance. So IX तो सीधा सीधा निकल गया. How much?
19.
18 volts upon 6 ohm. That is 3 ampere. Now this is 3 ampere current. Up you know this current, you know this current, you know this current. Only यही तो current unknown है. Okay. Now you know. Now you find out the current IA. So now incoming current is what? 8 towards this node. So this is the one node. This is the one node. Okay. So current is coming here. 13 ampere is towards 13 ampere. 13 plus 8. Okay. And leaving current is IX plus IA. Okay. I want IA. That is 21. IX already is we calculated how much? 3. So this is 18 ampere. So IA is 18 ampere. Okay. Now what is RA? Tell me. What is RA?
1.
1. Okay. The voltage across is 18 volt. Current is going 18 amperes. So 18 volt divided by 18. Okay. That is 1 ohm. Okay. This is circuit. So yeah, simple circuits. Okay. Using KCL. Now tomorrow we learn about the KVL. और सिंपल सर्किट सॉल्व करेंगे पहले और फिर थोड़ा धीरे धीरे slowly we will make the complexity. Okay, then we'll learn techniques, then we'll learn theorems. Okay, so first I am only dealing here with resistive circuit. Circuit में खाली resistance है. There is no inductor, there is no capacitor, there is no AC source. So only DC source, resistive circuit with DC source. Okay, then we'll bring capacitor and inductor, and then finally we bring AC source whenever we require. Okay, so I'm stopping here. If you have any question, please ask. So thank you. I'm stopping.
Okay, thank you, sir.